Welcome guys in this new tutorial about making a procedural tank track. In this video I'm going to show you how to make it using a different approach than the other videos already on YouTube. So let's get started. I'm working with Blender version 4.1.1 and the idea behind this project is to create and manipulate a curve as you want, adding several wheels controlled by the control points of the curve and instantiate a piece of metal all around these wheels. So to start, I remember you to look at this screen case result. If I forget to mention some commands inside this video, we can press 1 to go in the front orthographic view, press Shift A and add a simple curve circle. We can enter in edit mode, press A to select all the control points, R and X to rotate by 90 degrees on the X-axis. Keep in mind these are the control points, so the wheels we want to have inside our tank track. So in this case I will subdivide these segments with the right button, subdivide like this, and I will move these on the Z-axis a little bit like this. Now the idea is also to have the control of the radius of these control points, to have a different radius of the wheels inside. To do this, I remember you to go in the item section here and play with the radius of each control points. So for my example, I will set for these three control points a value of the radius of 0.5, hold Alt and Enter to set the same value to all these 3 points at the same time. Otherwise you would set the value only on the last selected element. Now we can go in this plus menu, General, Geometry Nodes, and press New to create our new Geometry Nodes system. We can press Tab to exit from the Edit menu and change the scale of this curve to have a more realistic dimensions. So we can set here 100, press Ctrl A to apply the scale, and we have nearly 2 meters on the X-axis. Now, inside our geometry nodes, we can press 1. Now we need to create the wheels on our control points, and to do this we can press F3, circle curve, and we can set 64 segments. We need to leave 1000 millimeters, or if you want to change the unit here, set these to meters and leave this value because we are going to change the scale of each wheels based by the radius of the control points of the curve. So in this moment we have this geometry that is a line, and we need to transform this geometry, rotating these on the x-axis because we want the circle from this point of view. And now we can simply press F3, instance on point. We can link the original curve geometry and link this transform to this instance and link this to the geometry. Now let's change the scale based by the radius, so you can set the radius field inside the scale. Now we have a problem. Why? Because I changed the unit measure, but inside our control point I have a changed radius, so I need to go again in the edit mode and check the correct radius for all these control points. And as you can see, when I had 1, now I have 100. So keep in mind to change the unit measure before these settings. So press A to select all the control points, right button, set curve radius by 1 for all these points, select these points, right button, set curve radius 0.5 and press Enter. We can select all the control points, press S to have a little gap between these wheels, exit from the edit mode. Now we have our wheels, but we have 6 instances. So to make the perimeter of this tank track, we need to convert these instances in real mesh. So from these we can realize instances to have the vertices of our mesh. As you can see here, we don't have a real mesh, we have control points of 6 splines, but not instances. We can select all these nodes, Ctrl J F2, wheels, creation 2D. Now from these we have 2 roads, one for the making of the perimeter and one for the making of the real wheels. First we are going to create the perimeter around these wheels, but I'm not going to use the convex hull node, so F3 convex hull node. Why? Because this particular node, yes, it makes the correct surface around, but if you go in the wireframe mode, you can see this bad result that is very difficult to clean with other nodes after this, and this is because the convex hull calculates not a surface but a volume, and it calculates the volume also in this case when I'm using simply curves. So because this is very hard to clean, I tried but I stopped myself. I'm going to use a different technique, so I delete this node, and the idea is to calculate the bounding box of the entire object, calculate the average point of this bounding box, make a very big circle starting from this middle point, and next project to the nearest point of the surface this big curve. As the result, we are going to have this magenta line. Next, we are going to resample this curve and instantiate our piece around. So step by step, we need to create the bounding box of this geometry, and using the mix node, we can take and find the middle point between these 2 points, so the minimum points that is here and the maximum points that is here. And if I press Shift Alt and click, you can see the bounding box, and limit this factor 0.5, I have the mix value between the minimum and the maximum position. Now I can create another curve circle, but I need to set a correct radius, enough to be always away from the bounding box of my object if I move or add other control points inside. So to set a correct radius, we can calculate the distance between these minimum and maximum points of the bounding box, so the diameter of the circle that contains this bounding box, and multiply this value, for example, by 10, and link this to the radius. We can turn on the snap tool, and now to make an instance of this curve in the exact position of this mix, I can make with F3 a point and position this point in the result of the mixing value, so the average point of this bounding box, and add an instance on a point here linking this curve circle. Also in this case, if I press Shift Alt and click, you can see the horizontal line that I need to rotate on the x-axis. So this is the bounding box, very small, and this is the circle around the object. From this I can realize this in a set of control points because I have one spline. Now to use the geometry proximity on this realized instance, I need to get the realized instances of my wheels and convert the curve to mesh, because the geometry proximity works only for meshes. So remember this step, otherwise you would get an error by the geometry proximity node. And from these I can add a geometry proximity node looking for the points of my wheels. Before setting the position of my big circle, I can resample one time this curve in a proportional way, so based by the length of my curve. So I can add a spline length and multiply this value by 2 to have more values in this count. Shift and Alt to have the control points. As you can see in the spreadsheet, we have nearly 1000 control points, and now we can set the position of these points based by the geometry proximity position. Link these to geometry, and voila, we have the correct rounding curve. We can select all these nodes, Ctrl J F2, convex hull for making the track. Now from this shape, maybe you cannot see it, but these 1000 control points are not equally distantiated around this object. So we have lots of points in this beveled part of the curve and very few points here near the linear part. Why? Because from the biggest curve, the geometry proximity took the points and moved them to the nearest point on the final curve. This means that we need to resample the entire curve another time inside our geometry to have a more correct distribution of points on this curve. So we can use another time the resample curve and set a high number like 128. If you need to, you can adjust in your project this value based by your size of your curves and environment. Now, next step, from this output, we need to push the curve away based by the normal of the curve to offset this curve. Why? Because we have to instantiate our object, our final little piece. So we need to offset the curve and then instantiate our object along this curve. So let's make our piece. I can go in the layout. Let's make a cube with mesh cube. We can set 0.2 by 1 by 0.2 size. Shift Z to see the object, press 7, Shift Z to see the wireframe mode, tap to enter in edit mode, Control R to create 2 loop cut like this. Now we can take with 3 this face and this face, extrude by 0.1 in this direction, and we can take these, extrude 0.1 in this direction. Press 7, Alt Z to see through the object and enable the X-ray feature. Press 1, select these vertices, G, Y 0.03 to move these in this direction, 0.03 minus, and the same for these 0.03 minus, and these vertices G to move Y 0.03. Now, from this object that has a wrong scale, remember to press Ctrl A to apply the scale, go to the modifier, Shift Z to see the object, and we can add a bevel modifier setting 0.02 and 5 segments. Right button and shade smooth, and this is our piece. Okay, now we can go in the geometry nodes system. We can select our curve, press N to see this sidebar, and under the attributes we can add a new attributes that is the track piece, and this is an object type. We can select from this the cube, and now we can add with F3 a group input node, and from this we can get the object information. And because we need to offset this curve a little bit based by the half of the height of the piece, of this piece, we need to take from this a bounding box of this object, take the maximum, subtract the minimum to get the difference diagonal vector of this object from the minimum point to the maximum point of its bounding box, and from this we can separate the components, getting only the Z component. The Z component, because in this case I made this piece in this direction, and from this I need to have half of its height. So we can take these and multiply by 0.5, and now we need to set the position of the points of our curve by what? By the normal of our curve scaled by this value here. And now if I move this here and link this to the geometry, you saw a little bit the offset. But there is a problem. I would not suggest you to use the normal, because making this curve, you could have a bad normal of the control points along the path. Okay, so to have a better position, I would suggest you to use the curve tangent of the curve that is already well defined along the path, and using the y-axis, so the perpendicular axis from this point of view, we can create the correct normal on our surface. And how can I make it? So we can use the cross product node, dragging this tangent in the cross product node and setting -1 to the y and linking these to the scale. So the result seems the same, but it's more precise. And how it works, I remember you, the cross product is the result of the multiplication by two vectors. And you can see my other videos in which I discuss this node. And the result of this multiplication is a new vector perpendicular to the plane where the original vectors stay, and the direction of this vector is based by the angle between the first and the second vector you multiply. So if you increase the angle more than 180 degrees, or you invert the order of the two vectors in the multiplication, you will get the same vector but in the opposite direction. So not this direction but this direction here. So this means that if you don't remember the result of the direction of this vector, you can see the base axis of your environment. So remember, the x as the one vector multiplied by a second y vector gives us a third direction like the z-axis. So this is the order: x cross product y equal z. In this case, if you rotate this axis with this coordinate system here, you can imagine here the x here, the y here, and the z here. So the correct order of multiplication is the tangent of the curve, this is the tangent of the curve, cross product the negative vector on the y-axis. Okay, so this negative y, and this is why I set here the tangent as the first vector and then -1 on the y-axis. To get what? To get the correct outwards vector of the z. If you want to invert this offset, you can easily invert this -1 with 1, or invert these two vectors in this cross product node. Okay, now I can press H to collapse, H to collapse. I can select all these nodes, Ctrl J F2, offset along normal, pre-instantiation. Now, because the system doesn't know the correct distance I want to use to instantiate this piece on our curve, because I cannot use the bounding box X size, so I cannot use this size to separate and loop the object on the curve, because I would not have the intersection of these pieces, and I want to have this intersection effect. So to do this, I need to add a new attribute inside my crew node to specify exactly the constant distance I want to maintain between one piece and the other. So at this point, I can add a new attribute here that is a float value called piece distance. I can set this to a distance, set 0.0001 as the minimum value and single value. Now I can try to instantiate this piece around my curve. So press 1, I delete the annotations, press instance on point here. I can get another time the group input node, take this track piece, get the info data of this, and link the geometry inside this instance, but we need to correct the rotation around this circle. To do this, I will use the famous method of double align to Euler vector and not Euler. I learned this name correctly, and it is like a boiler, so Euler. We can add another time the curve tangent node and link these to the align to Euler rotation, and we can link the tangent to the vector of this align Euler to vector. And what we want is to align the x direction, so this direction of the single piece, along the tangent of the curve. And to do this, we can leave the x because we want to rotate the current rotation of the original object, aligning the x direction to this vector here. And we can link this to the rotation, and voila. But keep in mind, because we can have a correct rotation along the path, but a tilting if something's wrong in the making of the automatic curve from the system, we need to duplicate this another time, saying to the system that we want to maintain the pivot point on the x, so we want to maintain the previous axis we used to align the tangent, the rotation to the tangent, and maintaining the y-axis of the original object on the y-axis of our curve system. So we want to align the y on the y-axis, and with this operation you are sure to have always the correct orientation of all these pieces on this curve. We can select all these nodes, Ctrl J F2, track instances and alignment. Now we want to have more gap and distance between these pieces, so to do this I need to resample another time this curve, last time, based by our piece distance. So imagine I want to set 0.3 meter, for example, and we can resample the curve by this new attribute. So I can add a group input and link this piece instance here, but setting not count here but length, and link these here. Now I can link these into the instance of points, and as you can see we have a little overlapping of the objects, so I can increase a little bit the distance, perfect, like this. Okay, so we have a little gap and not intersection. Now we can animate these pieces along the curve using a new attribute here. So I can add a new float value like the animation. We can leave these values as is because I want to be able to go in one direction or in the opposite direction for the animation. Set these to a single value, and now what we need is to reset the position of all these control points along the length of the curve itself. So what I need is a set position, it's obvious, based by what? Based by the sample curve, and through this node I can use the factor and play with the factor, getting the new position for all the control points. So what I need is not the resample curve as an input. Why? Because this resample curve, I'm sure that it has less points than the original resample curve, and because I need to maintain the correct position of the new piece along the original and detailed curve, I want to get the correct new position based by the original curve and set the new resample curve points position based by the result of this sample curve. So in this way I needed to take the piece distance. So imagine we have here the 0 index, here 1 index, here 2 index, etc. And between these two pieces we have the distance we set here in the piece distance. So this means that I need to proportionally calculate the percentage of the factor of each of these distance along the entire length. So if the length of the curve is 10 meters and my distance is 0.1, I need to convert this range in a range from 0 to 1, because the factor, so the value from 0 to 1 from the start to the end of the curve, needs to be divided in little pieces and have for each piece I instantiated the correct little step of the factor along the entire curve to move each piece in the correct position on the curve. So this is an easy proportion, so 0.1 divided by 10 equal to x divided by 1. So to get the correct x in this range of values, I need to divide 0.1 and 10, so the piece distance divided by the length of the curve. So I can take these and divide by what? The spline length of my curve, and what I need is to multiply this little value in a domain of range between 0 and 1 by each index of each piece to get the correct value of the factor to set here inside this sample curve. So if I multiply this little distance by the index of each point that I remember you is from this resample curve, and link this value to the factor socket and the position in this position, as you can see, nothing changed. And now if I add from this a value in this factor, as you can see, this is what happens. So I'm adding a value to all these pieces, so I'm shifting the value inside of this sample curve, getting the new position output here. And if you don't know, if you go over the value of 1 inside this sample curve, you always get the position of the end point of the curve. And it is why if I increase this value, I have the shifting of the first object along the curve here, the second here, the third here, and so on, but the others are all on the same position at the end of the curve, and all the pieces that have the value of the factor greater or equal 1 inside this sample curve have the same position at the end of the curve. So to avoid this and let the system loop the piece from the end of the curve to the start point of the curve, I need a simple fraction node here. And adding a fraction, all the values greater than 1 start again from 0. So if I link these, as you can see, I can increase these, and you can have the correct animation and loop of these pieces along the curve. So instead of using these custom values, we can easily duplicate the group input and link the animation attribute inside this add socket. Press H to collapse, H to collapse, H to collapse, and voila, we have the correct animation of the pieces. Select all these nodes, Ctrl J F2, animation track points. And now I can play with this animation, as you can see, and move the pieces around the curve. Keep in mind the correct length of the curve to not have intersection between the last object of the curve and the initial object of the curve. So for example, if I take this curve, go to the edit mode, press 1, and now I take this point and move a little bit. As you can see, in this point here, you can see the intersection between the two objects and the problem about the initial rotation of the instance. And the good thing is that you can manipulate the points where you want, maintaining the correct distance between the curve and the radius of each control point. Now let's make the wheels. So this is one road, the other road is here. So I press Shift Alt and click to see the curves. And before filling this curve to have the real wheels, I'm going to transform the geometry back on the x-axis by 90 degrees, like this, because the fill curve in this way works always on the plane of x and y. So if you forget to rotate the object, you can't see the result of the filling of these curves. In one of my previous tutorials, the procedural Shify sphere, I described a little trick to be able to fill any curves from whatever position they are. So I will leave the link here and in the description, so check it out. So from now I can use the fill curve, setting the N-gon to have a few faces and triangulation. Now I can duplicate this transform and re-rotate on the X as the original rotation. Now we can add on our group node a new attribute, so the wheels width, and this is a distance. And if I want 0.5 width of these wheels, you have to be sure to shift by half of this width to extrude this object. So from here I can extrude this mesh by what? By the group input wheels width attribute, like this. And if I press Shift Alt and click, you can see the extrusion only in this direction. So I needed to shift the entire object by half in the opposite direction to center and align in the center point all the wheels. So if this is the middle point, I can use the same wheels width multiplied by 0.5 to have the half part. Link these to a combine XYZ and linking this to the Y direction. And I want to move these in the translation of this transform geometry. So now here in this point, we have the middle point of the wheels, the shifting in this direction by the half of the width, and then the extrusion by the entire width. To be more precise, I can link these to a vector of the offset and set -1 for the direction of the axis we want to extrude. Then if I enable the face orientation, you can see the correct extrusion, but we can't have the cap here. And to close this surface, I need to take the original fillet curve and the flip faces. There are these faces here, remember? Okay, the normal of the blue and the red. And next we can join what? These flipped original faces with the extruded faces like this. Shift, Alt and click. This is the entire shape of the wheels. And in the final step we need to merge by distance the vertices. We can hide the face orientation, delete the annotation, and this is the result of our wheels. Now we can select all these nodes, Ctrl J F2, 3D wheels, and the final step we can join what? These wheels with this track using the Shift, Ctrl and right drag between these two nodes. And because we have these sharp edges, we can add another modifier here, like the smooth by angle, ignore the sharpness, and this is the final result. We can hide the cube, rename these geometry nodes in Tank Track, rename this curve in Tank Track, and if I go in the layout and go to the edit mode, now I can move these control points around my mesh, always getting the correct curve around the wheels. And at the same time I can animate this animation socket. If I want to animate this object, I can subdivide these segments another time and take these and move down, for example, and decrease or increase the radius as I want, and play with these values. We can set a little material like metallic. We can enable metallic and decrease a little bit the roughness to 0.1. Go to the geometry nodes, and before the group output we can add a set material, for example, and set the metal material, setting the name as Tank Track. I'm showing you this set material, but it's obvious maybe you want to assign a different material for this part and the wheels. If you don't want to use this basic shape of the wheels, but you want to use a custom object, you can do this. So you need to add another object attribute inside our group node, and instead of using this approach, you can easily do this operation. I'm going to show you this part, so I'm going to add another input and set, why not, set these to object, custom wheel, and maybe we need to use another input as the use custom wheel as a boolean attribute as the single value. So here we can add a group input, and this is the first time I do this part in this video. Why not? Good, the first one, as we say in Italy. We can ask if the use custom wheel is true in a switch, and instead of using this geometry we can move this a little bit. If you want to use the custom wheel, we need to link these into object info node, instantiate these wheels inside the control points, and link this output in the true. Otherwise we need to use this false method and link this to the join node together with the track. So now if I make not a simple cube, but for example a gear, okay, this is my wheel, for example, rotate on the X by 90 degrees, we can decrease the size by this, Ctrl A to apply the scale, SY a little bit, I want to have a 0.5 meter on the Y, Ctrl A and scale, and this is my wheel. Now I can go in these my geometry nodes and select my wheel like this, and if I want to use the custom wheel, as you can see the original wheels we made disappeared, and this is correct. But now I need to instantiate on our control points. So where are they? They are in my original geometry, so I can use this geometry in an instance on point like this and link my gear inside and link this to the true. But the rotation is wrong, and it's obvious because I have the plane of the X and Y rotated by 90 degrees on this curve, so I need to apply the rotation of my original gear. Indeed, if you select the original gear, you can see the X rotation, so I need to apply with Ctrl A the rotation, and this is the correct result. But we need to set the correct scale by what? Based by the radius. So if my radius radius of the control points are these. This is the correct result. We need to tweak the scale a little bit. Why? So currently we don't have to scale also the y-axis because the gears needs to have the same size on the y and needs to be resized only in the z and x. So instead of having the radius in all these three dimensions, we need to use this in a combined x, y, z and use the original scale separated in its component using the original y and linking the radius in the z and the x and linking this to the scale. In this way we can have the same size on the y-axis. We can hide the original wheel, and because the size of our wheel is nearly 1 meter but we have a radius, we need a diameter, so we need to multiply by 2 to have the correct resize value of the scale of these instances. Okay, this is a single gear, and if I press 1 you can see we have the radius from here to here, but the dimension of these needs to be twice to fill the correct dimension of the wheel inside our curve. So for this reason I need to multiply these by 2 and link these to the x and link these to the z, and voila, this is the final result using the custom gear. So now I'm thinking, making this tutorial, that I can add the animation also on the wheels based by the radius. So with the radius and the animation I can calculate the correct rotation of the piece. Let's give it a try. We can go in the geometry nodes, press H to collapse these, H to collapse, H to collapse. So before I rotate the instances I need to save the information of the radius inside the instances, because after I would lose this information. So before I need to store name attribute inside the control points of my geometry here, and I can save the v underscore radius as the variable and link the radius inside, and after this operation I can duplicate these, linking the use custom to make this workflow more readable. And here I can use the rotate instances, and let's make a try. If I rotate on the x, not is the correct, the y-axis perfect, all the direction is correct. So if I go in this direction, increasing the animation, I need to decrease the y. Okay, so I need to scale this rotation by the radius of each instance. So I can get the name attribute. This is the first time that I extend a tutorial while recording, and as you can see this value here is not a value in a unit measure, because if I go here in the animation track point and you see this add mathematical operation, I'm going to add a value that affects the original piece distance and on which I do a fraction to get the value always from 0 to 1. If I go on value 0, 1, 2, 3, etc., I always get the same position for all these pieces. So this means that I need to get the group input animation and multiply this value to have a correct distance and not proportional factor of the curve. So I need to multiply by the length of the curve, but I'm sure to not choose the wrong curve, so not the original curve of the geometry, because the original curve is passing through the control points here. Okay, the original control points, but I need to get the length of this last curve around the wheels, so the correct curve is this in the previous moment of the animation when I resample this curve, and I need to get the length. So to do this I need to add a sample index. I need to link this curve, so for this reason I can move all these nodes a little bit in this direction like this. From this I need to get the spline length, and to not make mistake, maybe I need to save this information before the instance on point, otherwise I would lose this value in the instances. So I go here, duplicate the store name attribute another time and set length, and for this reason I'll take these two nodes. I go here, move this a little bit, sample nodes, length value. I leave this index 0 because I have only one curve in my object. I link this to the length, so in this way I can save this information. Now I have the radius for each point and the same value of the length of the curve for each point, but the correct length. And now I need to go here, multiply this value of the animation by the length. I need to have the correct length value, so if I have animation of one value, I need to get the total length of the curve, and with this distance I need to divide it by the radius of each control point. Why divided and not multiplied? Because if I have a wheel with a big radius, the rotation needs to be slower than a wheel with a small radius. So more is the radius, less is the rotation, and vice versa. So now I can link these in a combine XYZ only in the Y direction, it's obvious, and link these to the rotation. And let's try. If I move these, okay, the rotation is in the wrong direction, so I need to multiply this value by -1 to invert the rotation. Okay, it's correct. I press 1 to see the result. Okay, in the wireframe mode it's correct, but there is a bug here because the end of the wheel, the object of the wheel, is here, but needs to be not in this point but in the middle point in the curve, and this is a mistake. And to prove you this, I increase the radius of this point, and as you can see we have this problem emphasized here. So the problem is the scale of the instances, because I need to multiply by the scale of the original gear. So if I enable the view of the wheel and go to the dimension, as you can see we don't have 1 meter by 1 meter in the X and Z, but 1.09. So to have a correct scale we need a proportional scaling of this value before going in the scale of the instance on point. And to do this, because we don't have the dimensions of our gear, we need to move this a little bit. We need to get from this object the bounding box. We need to subtract from the maximum the minimum point to get the total size of the object, and here we can separate the components. And if we have an original size of the wheel too big, we need to scale down to adapt the scale in the correct radius of the wheel inside the curve. If we have a small size, so below 1, we need to increase the scale. So we need to take these values of the radius multiplied by 2 and divide by 1.09, so the X or the Z. So I can press H, H and H, and we can take these and divide by the X component before going here, and you saw the difference, the distortion of the object. And because the gear or the wheel has the same size on the X and on the Z axis, we can use the same value output also for the Z component. And as you can see, we don't have the problem because the final part of the object ends near the exact middle of the curve on which we instantiated the pieces. And now is correct, so I can go here and set 1. We can hide this, press H, we can move this a little bit. We can select all this group input, go to select, select grouped type, press H twice, press H, H to collapse, and this is the custom part of the wheel. So we can select all these nodes, Ctrl J, F2, custom wheels and rotation. exit from the edit mode, Shift D to see the object, and now the animation is correct. Now I want to show you a last part of this tutorial that you can use maybe for your projects, and it's a different approach, and it's like a sort of shrink wrapping or constraints on a floor. So to apply this effect you cannot use the floor or the shrink wrap constraints or other stuff like this, because the problem of this surface is that if you have a displaced floor you need to maintain this object on this floor, but keep in mind we have a different radius. So if I take these and set a radius like this, for example, I need to be sure that this point stays to the correct distance. So let's make a floor. We can create a plane, we can scale it a little bit, tab, right button, subdivide 10 times, and we can re-subdivide another time like this. We can go in the top view, press 1, we can delete some of these surface we don't need, like this, press X and delete these faces. This is our floor. We can add a displace effect, creating a new texture. Go here in the properties, we can change the image to clouds and increase a little bit this value here, and we can leave these as the floor. So the idea is to adapt the height of each control point of our original curve on this floor. So to see the difference, I will go to the preview of the material and add a new material like this, and I will increase to 0.4 the roughness of our tank track. Now the idea is to project each of these control points on this floor, and if we have certain conditions we need to reposition the control points on the floor itself. So to do this we need to take the original geometry. So keep in mind, in the new part here of the custom wheels and rotation we cannot use this original geometry, but we need to use the changed geometry by this part. And to do this I will create a new route here and make a reroute, the same here, and I will link these to this geometry. And I think I'm not using the same group input geometry in any other part of the workflow. Yes, perfect. Now this is the last part of the tutorial. So to project these control points on the floor we can use the raycast node. So the target geometry is our floor, so we can add two attributes here. One is to use the floor, and this is a boolean attribute, and one other that is the floor object. So we can set these to object, go to the modifier and select our floor. I can rename it in floor. Perfect. The floor is a single value, and now from this floor we can get the object info and set it on the raycast target geometry, and we can use from what the position of our control points of the curve to set the new position in the space. So before linking the hit position here we need to ask if the control point projected hit the floor. So if this is true, we need to calculate what. So I press 1 for a moment, and the idea is this. If this is true, we need to ask another thing. If the distance between the control point and the floor is less than the radius itself. So for example, if this is the point and this is the floor, this distance is greater than the radius itself that goes from here to here. And this means that I don't need to do anything. If this distance is less than the radius, so for example in this case where this is the position of the control point and this is the point of the floor, for example, this distance is less than the radius. So in this case I need to move the control point up by what? By the difference between the radius and the distance itself. So I need to push up the control point by this distance to have the final part of the wheel on the floor itself. So if the hit distance is less than the radius of my control point, and I need to set these in a new switch, setting the float. So if this is true, I need to take the radius and subtract the distance and link this to the true condition. Otherwise, we have a correct position of the gear over the floor in a original distance, so we don't need any offset. So this is the output for the true condition of hitting, and this goes here in the true condition. In the false condition, so if we have the gear under the floor, like in this case, we don't have any hit distance, so actually the system would give us the rail length itself, so a wrong value. So if we don't have any hitting, we can do the same operation of projecting, but not in the negative Z direction, as you can see in this socket, but in the positive Z direction. In this way, I can get the correct hit position and add the radius itself to shift the wheel up on that position on the floor. So I can take this raycast, duplicate, I can link the same geometry in the target geometry and the same position as the source position, but in this case I'm going to set 1 for the direction of the projection from the control point to the floor, and from this I will get the hit distance adding, so the distance between this point of the control point and the floor itself, adding the radius value itself and using this inside this false condition. In this way I can link this output in a combine XYZ, linking this to the Z component. It's obvious. H to collapse, and to be able to make this workflow more readable, and link this to the offset. But there is a problem. Why do we have this behavior? Because our floor has a wrong scale. So remember, apply the scale with Control A scale, and as you can see, all the information inside the displays modifier now are wrong. So I can go in the properties of the image and increase more this value, go to the modifier and increase a little bit. I can press the right button, shade smooth, and now this is the result. So I can go to the edit mode and delete this vertex, for example. And as you can see now, if I move this object enabling the Gizmo, you can see if I move up and down this object, we have the correct behavior. I go to the layout and enable the preview. And as you can see, if I move these on the surface, I have the correct adapting of the wheels. Keep in mind, it's not a perfect system. It's only a way to make some inspiration, because it's obvious in this case, here we have the problem of the instantiated part. So not only for the control point, but also for these instantiated pieces, so the control point on this curve, we would need to tweak the height of this piece. And not only this, you can see the correct behavior if I go down under the floor, but we have intersection between the wheels, so maybe you need to move the wheels a little bit away from themselves to have a behavior like this, and in this way you can play with the animation. If we want to be more precise, we could add to this radius the half part of the object we instantiated. So in these geometry nodes, we can go here in the offset along normal pre-instantiation and take these nodes, Ctrl C, Ctrl V, ENG, and here we can add this value before using it in the switch, using it here, and you can see the offset now, okay, as you can see. Or if I go not under the floor but in the middle distance like this, you can see the mistake, the wrong offset, because we need to add the same value also in this case when we subtract from the radius the distance. So we need to go here and take the same value and then link this here, and now we have the correct position in all the cases. Now it's obvious if you move this object and the length of this curve changes, you have a different number of pieces instantiated on it, and you could probably have a different behavior while animating the track, because the number of the pieces changes at the same time. We have also this problem here of the rotation of one piece, so keep in mind this in your project. And it's obvious this happens only if the length of this curve changes. Otherwise, you don't have any issue. We can press H to collapse, H to collapse. We can select all these new nodes, Ctrl J, F2, floor, and finally we need to control the switch we added in the group input, adding it another time and asking if we want the new geometry or the original geometry. So in the false condition we want the original geometry, otherwise the changed geometry of the control points, linking these here. Move this inside this section, Ctrl H. So in this way I can enable or disable, as you can see, if I move this under the floor, and enable or disable the using of the floor. Last tip, if you want to use the X movement of this object as a driver for this animation, you could click with the right button and select copy as new driver, and right button here, paste driver. But keep in mind, in this way, if you move the object on the X, you can see the wrong proportional values here. Why? Because we have a different length here. And why this? Because we are using the animation as a factor for the sample curve node. So if you need this relationship between the X movement and the animation socket, you need to go to the geometry nodes, and instead of using the factor socket of the sample curve here in the animation track points, you need to set length. You don't need to use the fraction but the module linking the length of the entire curve, because the fraction is used only if you want to have a maximum value of 1 and not a more bigger value. So in this case I need to restart from 0 when the value is over the maximum length of the curve, and link this to the length, delete the fraction, delete this divide, because here we have the distance from each pieces and it's already in a unit measure, so in meters for example, so we don't need to recreate the proportional value from 0 to 1, and we can delete this node. And not only this, but keep in mind, in this part of the custom wheels and rotation, we used this animation multiplying it by the length of the curve itself. So in this case we don't need this multiplication, because the animation itself is a length with unit measure, and you don't need to store any length in this way, but only the radius for the control points. And now if I go to the layout and move the X, you can see this movement here. So to correct this rotation, you need to go here, right button, edit driver, and you can change the average value to scripted expression and multiply this value by 1 or set minus if you want. And now if I move the X, as you can see, the correct following of the animation here. Or if I want to use the floor, this is the result after this operation. A last tip I can show you, and for this I will scale on the Y a little bit this to get this object, and let me rotate this. And as you can see, if I move this on the X-axis, I have the wrong translation in this position. Why? Because I'm translating something that is rotated. So to use the correct local axis and maintain this relationship between the rotation and the translation, you don't need to rotate anything. You need to parent this object, for example, in an empty object, and then use the local X translation to drive your animation. So, for example, I create a plane, I reset with Alt and G the translation of my tank track, I reset the rotation here, I select with the control the empty, parent with object, and now if I rotate the empty on the Z axis, I can use the X, the local axis of my tank track, and have the correct behavior of the animation. And this was the last tip. Maybe in the future I will update this project, moving also the pieces around the floor to be more precise. And that's it. Thank you guys for watching this video. I hope you learned something from it. You can always download this project from my Gumroad page or make it from scratch. Thank you always for your support. If you liked the video, please check a like, subscribe to my channel, and don't forget to check the bell icon to get all the notification of my new videos. See you to the next tutorial. Bye!